Alright, so today we're going to talk about the distance formula and how it applies to the stuff that we've been doing. So find the distance between each pair of points. We can use the main way we can solve for or figure out the distance between 2 points is our distance formula. Square root of x2 minus x1, it could be flipped, it doesn't matter, squared, plus y2 minus 1 squared as well. And again, that could be flipped just like the x's can. If we plug in our numbers, I guess I have my y's first. 4 minus negative 3 squared plus 1 minus 5 squared is 7 squared and negative 4 squared. You should never get a negative number when you square a number. So if you get negative 16, that means you didn't put it in parentheses. If we put them both in parentheses, we get root 65, which is approximately 8.06. That's how far apart those are. Next, we're going to look at doing it a right triangle way. And either way is fine. This looks like a little bit shorter. So it might be something we want to do. But we draw directly over where the other point is, and then go right up to it, make a right triangle. So the distance is going to be the hypotenuse is going to be our distance here. We also could have gone up. You could have gone up to here, and then over to here. It's still 3 and 6, so it doesn't really matter. And we do Pythagorean theorem. 3 squared plus 6 squared is x squared. 9 plus 36 is x squared. 45 is x squared. Take the square root. We get 3 root 5, or approximately 6.71. Number 3, another right triangle. So here we only do 1, and we went over 6. So it's 1 squared plus 6 squared equals x squared, our hypotenuse, which is root 37, which approximately is 6.08. Number 4, now we can't really do the right triangle method because we don't have them graphed, so we have to do it the distance formula way. And again, it only matters that the points line up the way they should. So for instance, in this next one, negative 3 is our x, negative 5 is the other x. We put it in there. Then we start with the same point. We start with these coordinates. So it's going to be 7 minus 5 from over here. So we end up getting 2 squared plus 2 squared, which is 4 plus 4, which is 8, which is 2 root 2, and simplifies to 2.83. 5 and 6, the same thing, kind of running out of room here. Negative 4 minus negative 4 is negative 4 plus 4, so it's 0. 7 minus 3 is 4, so 4 squared is 16, square root of 16 is 4. Now there is another way that we could have figured that out. If you notice, the negative 4s are the same. So now we just take these two distances and subtract them. So we didn't have to do all that work. So if you can realize that either the x values or the y values are the same, then you can just subtract the other coordinates and you'll get your distance. But the distance formula always works as well. So we have distance here, negative 1 minus negative 6, which turns into plus 6. 4x minus negative 5, which turns into plus 5. And 4 plus 5 is 9, 9 squared is 81. Negative 1 plus 6 is 5, 5 squared is 25. So we add them up. Square root of 106, which is approximately 10.30. So that's how you find distance between 2 points. Either drawing a right triangle or using the distance formula. Find the slope of the line through each pair of points. So this is our y2 minus y1 over x2 minus x1. So it's very similar to the distance formula. But here we chose negative 6 first, minus negative 5, which turns into plus positive 5. And then we started with the negative 6 for the numerator. So the denominator we have to start with 17. 17 minus 15 is 2. Negative 1 plus 5 is negative 1. So our slope is negative 1 over 2. Same thing over here, number 8. Negative 17 from here minus negative 7 equals, or then we do negative 15 minus a negative 19. Now, as I look at this, I realize I did it upside down, which is not that big of a deal. So instead of negative 5 over negative 5 over 2, it'll be positive, or it'll be 2 over 5. See, those should be switched. Let me switch those real quick. So it's y's always go on top. Negative 15 minus negative 9 over negative 17 minus negative 7 equals. So, like I said, we're going to have the same numbers, 4 over negative 10, and we can simplify those both by 2. That's our slope, the opposite, or the reciprocal of the other one we got. Find the slope of the line perpendicular to each given line. So if we look at this, the negative there means that our slope is negative 1. Well, if we put that as a fraction and flip it, it's still 1 over 1. But now it's positive because perpendicular lines, perpendicular slopes are opposite, meaning we change the sign from negative to positive or positive to negative. And they're reciprocals, meaning we got to flip it upside down. Just 1 flipped upside down is still 1, so that's why m is 1 here. Here, we flip 3 over 2 to be 2/3, and we take away the negative to make it positive. Find the slope of a line parallel to each given line. Parallel lines have the same slope. The slope of number 11 is negative 7 over 2, so our parallel line will be negative 7 over 2. Same thing over here. It's 805 or 8 over 5, so it's the same as that one. Bringing back some older stuff. Determine if line AB is tangent to the circle. If it's tangent to the circle, we'll have a right angle at the point of tangency. So how do we figure this out? We use Pythagorean theorem. 15.4 squared plus 7.2 squared, 17, that's obviously the biggest, and it's across the 90, so that's the hypotenuse. So when we do all the work, we get 289 equals 289, which is true, so this is equal. So that means it is a right angle, so it does mean that AB is tangent to the circle. Number 14, same idea. The longest side is the 14. That's our hypotenuse. Our right angle, if there is one, is at A. So we got to add up both of these. This is the radius. We need the diameter, this whole segment. And we use our Pythagorean theorem. So 11.2 squared plus 9.2 squared all adds up to 210.08. 14 squared is 196, so not a right angle. That means AB is not a tangent to the circle. All right, lastly, the main point of what I want to do here. If I can get it to, there we go. So it says verify BD. Wow, that's awful. BD is congruent to DC. We want to deal with those two segments. We also want to deal with the fact that if we draw to A, there should be a right angle, and there should be a right angle here. So that's what we're going to look at. First, let's look at verifying that BD is congruent to DC. We use our distance formula. Or you could use right triangles. If we use the formula, the points are listed here. So 7 minus 4, 1 minus 4, both squared. We add them up, and we get the square root of 18. Now, we could simplify the square root of 18, but we just want to see that it's equal to the other one. So DC, 7 minus 4, 1 minus negative 2 squared, 9 plus 9 is 18. They're both square root of 18, so BD is congruent to DC. Now, verify that they're perpendicular. We got to find the slope of all of them. So again, just our slope formula, y2 minus y1 over x2 minus x1. Now we have the slope of BD is opposite reciprocal of DC and AB, but AB is what we wanted. And the same thing with slope AC and DC. They're opposite reciprocals. So we have all the work there. Again, it's in my notes, so if you're not catching it as quick when I'm talking about it now, just go to my notes. All right, number 18, same thing. We want to verify this and this are congruent, and we want to show that when we draw this in, it's a right angle. But I I want to take that off for a second so that I can do the other way we talked about, the right triangles. So we can start with point D, and let's just do the distance formula. So BD is 2 minus 5, 4 minus 3, square them up, add them up, square root of 10. DC, 5 minus 4, 3 minus 0, square them up, add them together, we get square root of 10, so they're both the same. And the same thing with our slopes. We got 3 and negative 1/3, 3 and negative 1/3. 3 is obviously 3 over 1. So they are opposite reciprocals, so we do have perpendicular segments here. So that's what we're talking about on the last day of this unit.